So thanks for this opportunity, sir. So I'm Aravind, and I'm a faculty in chemical engineering at IIT Madras. But today I'm going to talk as a technical lead and also the coordinator of Hydrogen Valley Innovation Cluster in Tamil Nadu. So there are three nice questions that are posed by Saraswat ji. And in fact, last year, September 30, you inaugurated the DST Hydrogen Valley Innovation Cluster. That's where all things have started, and very nice to see big initiatives happening in the country. So I work with, my valley has almost 40 industries and 2 consulates, and we have state government guidance, Tamil Nadu, which is an investment promotion arm for the state, is also with us, and also TIDCO, which is the Industrial Development Corporation Institute of the state of Tamil Nadu, is also with us. So we asked one question to everyone: what is that single most important thing that's preventing the green hydrogen transition? And everyone said, we have technologies available, but we don't have a proper piloting and demonstrated testing thing. Unanimously, everyone answered this question, sir. This was the answer to them. And we decided in our Hydrogen Valley, like before any investors or any company going to invest in a technology, they'll do a demonstrator and do a techno-economic assessment in our Hydrogen Valley and then see their capabilities. It might be a technology which is tech transfer from elsewhere. It might be a homegrown technology, whatever it is. So there also we kind of, like the question about what is the color, and we've also discussed this one in terms of decarbonization. The thing is that for India, it really makes sense to go directly from the SMR process to the green process straight away without going into the blue process. Because I think somehow our investments in identifying the place to sequester 3 billion tons of carbon dioxide, which are emitting today, and we are growing at a rate of 4% a year, is going to be phenomenally higher. I think it's really not looks feasible, at least to go into the blue transition, like what we typically talk about in all the research articles, technical reports, everything. And also, the next thing is that there is no single CCUS technology or sequestration technology so far is successful in the world. And I think we can go and look around that. So ideally, I believe, Saraswatji, we should go straight. India really made a clever decision to go into the green hydrogen, that National Green Hydrogen Mission. The word green is included there. And going into the next one, you talked about the best production technology. Yes. Yes, sir. The cost of carbon capture, first, let me not go into the technical feasibility. Assuming that even feasibility is available, the cost of carbon capture per ton should be less than $40 today. That's what I think people talk about feasibility. And on the other side, if we include that $40 per ton of carbon dioxide that we sequester, even assuming there is a place to sequester, then the cost of everything, the energy associated with it, and then cost of hydrogen produced through those processes will eventually go up. Obviously, it doesn't look economical. Sure, sir.
Coal with carbon capture utilization, the cost is $2.1 to $2.6 per kg.
Okay.
Okay, renewable hydrogen, the cost, today's cost, is 3.2 to 7.7, depends upon where and how the electricity, electrolyzer cost of electricity and all that. Even in 2050, when you will have the cost of electrolyzers coming down from today's $800 to $1,500 per kilowatt, and cost of power will come down from $16 per megawatt hour to $20 per megawatt hour.
Okay.
You are likely to have the cost of green hydrogen as 1.3 to 3.3. So this kind of a number, that the cost of carbon capture utilization is $40 to $50 per ton. I want to again correct you there. NTPC, anybody here?
Yeah, we have.
NTPC has set up a plant recently at Vindhyachal, where they are doing carbon capture from a thermal power plant which has got a very low percentage of CO2. You know, flue gases in thermal power plant, the percentage is not more than 12%. Even for that, the cost is only $25 to $30 per ton. If I do this, and that plant size is only 10 tons per day.
Okay.
If I scale it up, this cost will come down to less than $20 per ton. So kindly please don't spread this kind of myth that carbon capture utilization costs are very high, and hence the blue hydrogen cost will be more than the green hydrogen cost. In no way you can have green hydrogen cheaper than the lower. That's why I said, can you justify our decision to go green?
Yeah. So I think it's very encouraging to hear those numbers actually. So if that's true, that's really cool actually. Yeah.
All these conferences and seminars carry these myths forward, because successive speakers keep on reinforcing this, so it becomes a message. Nobody does in-depth analysis, data collection, analysis, and then present it. I have got the figures. Please go ahead.
Actually, that's really encouraging, sir. Hope if that happens, then I think it's really cool. Next one, sir. Regarding the production of hydrogen for the lower cost, what is that? I think the previous speakers today in the previous panel, I think really emphasized on different types of technologies and localized manufacturing, everything. In the battery segment, for example, one of the problems that typically, I work with a lot of battery industries on battery explosion, battery safety, battery forensics. And almost every OEM unanimously mentioned that actually that the test rigs available for testing their batteries to validate is quite small. So obviously, when we want to really localize the manufacturing, it can be we use our MSMEs to really do those manufacturing. And also it can be the large OEMs who can put up their after tech transfer, like we have seen a lot of JVs happening here. If you want to really quantify or test their new products, I think we need to have a lot of test platforms actually, Saraswati. I think probably we need to really enable that so that on one side, really a lot of nice things happening on the like tech transfer and also indigenization of manufacturing. Parallelly, if you put up this validation test platforms, I think that will really couple the synergy that everyone has.
Sir, you are from IIT, no?
IIT Madras, yeah.
I would have expected you to tell me that if there are 10 processes of manufacturing hydrogen,
Yeah.
according to you, if you have done your research adequately on the processes, you are talking of, we don't have technologies to scale up. You should tell me which is the right process for India to be adopted to produce green hydrogen.
Yes, sir.
I expect the wisdom coming from IIT.
Definitely, sir. I'll answer that. I think there cannot be just one answer, I believe. Of course, yes, sir. Definitely. Sure. Thank you.